who's director of digital enterprise at Siemens. We ran into Siemens a couple of weeks ago at Jet Zero, and the process that they're using for digital transformation in building this company and building the blended wing body jet is quite intriguing. We've known Siemens as a manufacturer for many years. You've got the reputation of being controls. What is it? A little bit about what you guys are doing. How that's
They were like partners. Uh, you know, in the world on a plane occasionally, and this product is going to significantly change that whole entire experience. One of the things you mentioned about Siemens, which is true, is we've been known in decades past for our automation and motion control capabilities in the factory. About 20 years ago, there was a vision at Siemens by senior leadership that by bringing the virtual capabilities along with the real and merging them into what we call the digital enterprise, there was significant value to be gleaned from the throughout process of not only designing and verifying and validating a product, but also being able to take that digital transformation into the factory and be able to build a digital twin of the factory as well. So the merger of the software capabilities acquired by Siemens back in 2007 into this digital transformation ecosystem is what we're working with Jet Zero to employ so that they can build the Z4 platform and really impact aviation.
It sounds like you've got an interesting process in terms of the digital transformation, digital twin. You've got a digital twin of the airplane itself and the production factory to build it. And then you've also got the digital twin of the airplane once it's in service to do MRO and predictive maintenance. So you really hit a lot of different sides as you digitally integrate. How integrated is the system in terms of your software when you say you're going to integrate the plant with design work and design tools? Do you go right to the CAD CAM systems for designers? How does that work?
So really, there's connectivity throughout the entirety of the life cycle. Certainly, it's not all 100% complete, but almost every stage of the process, from conceptual design of the product to the detailed design to validation and verification and testing and simulation to manufacturing planning and manufacturing process development to manufacturing execution and actually the build on the shop floor. We connect all of the critical phases of that product development process as well as the factory with what we call digital threads. And these are connected data connections across the life cycle to the business processes that are entailed in building the product as well as building the factory. And this informs us of what critical information needs to go from one system to the next so that we have that what we call operational insight into what is needed to be performed from one stage to another as you go through the design and development, what we refer to as define, realize, and optimize of the product, as well as the define, realize, and optimize cycle of the factory itself.
What kind of benefits does this bring? It sounds like this is a way to change the schedule of projects and shorten them a little bit and bring them into focus a little quicker. Also, probably brings some savings in it as well, I would imagine. How do you describe the benefits and the advantages this provides?
Well, I think you hit on a couple of them. For sure, there's tremendous cost reduction. There's quality increases. There's reduced in cycle time and throughput of the factory of the products, as well as quality gains to be had. The way this happens is when you have the data connectivity from stage to stage, and you create what I referred to earlier as that operational insight, situational awareness. When you have manufacturing that is aware that a change is coming from engineering before the change is completed and can be involved in the collaboration on how that change can be implemented so that it will enable an efficient manufacturing process, all that leads to the capability of lowering the disruption to the operations process as that product or part or subsystem goes through the manufacturing process. We need to involve all of the critical disciplines like manufacturing operations, quality, test, early on in the design phase, and that's done through the digital thread and the digital twin, as well as um, basically the backbone that we call PLM, which is from our standpoint delivered through team centers, the backbone throughout the life cycle.
Sounds interesting. How does this impact? Is there a percentage savings that you folks have experienced with some other examples in terms of reducing development time? And what can we expect to see? Is this something that once you've set that schedule, it almost guarantees that you meet that schedule because you've got the data and information necessary to identify where things need to speed up?
I think to nail down a specific savings is difficult, but we certainly have seen anywhere from 10 to 30% in savings in costs and similar 20 to 25% reductions in production time. But I think that the main thing that we're seeing is that you come out of the chute when you define a product and start to build a factory that's going to build that product with much higher efficiency and effectiveness in producing that factory on time, on schedule, and with reduced changes and limitations or errors when that factory goes live. One of the things you mentioned earlier is that we provide our own uh, the industry. We make PLCs, we make HMIs, and we produce those in factories as well as like smart infrastructure products in our own factories. And we have an example of a digital native factory that we created called SNC New. And we use a completely digital approach to build that factory that resulted in an outcome of less than 1% in changes after the factory went live of the total factory build cost, which typically runs much higher than that, anywhere from 10 to 12%. So
That's
the
very
changes
impressive.
required in the factory were significantly lowered by that process.
Very, very impressive. And in terms of the simulation capabilities, are those being used for simulation of the product as well in simulation of aircraft performance or simulation more of the manufacturing facilities?
I would say it's pretty much evenly across the board. We have tremendous capabilities for simulation of the product, like you said, the aircraft performance with things like computational fluid dynamics, thermal stress, vibration, flutter. All those kinds of capabilities are in our capabilities of SimCenter. And then when you get into manufacturing, we have a suite of tools that create simulations for the factory operation, things like plant simulation or process simulation. We also have process simulate human, which simulates the human workers, the touch labor that's on the shop floor. It allows us to be able to see the things that they can see when they're trying to turn a wrench or access a heavy component. It does joint analysis on their body to see if it's going to cause any injury potential. We can run the entire cell to see the the throughput of an individual cell and then combine that cell into a simulation of a total factory, showing all of the movement of the raw materials and tools and people through the factory so that we can get the throughput of a single day, a week, a month, or a year of operation, and then identify bottlenecks in the operation of that factory.
That's quite impressive. That's a from the beginning, from the product right on through to the manufacturing in the factory, and that's a very impressive capability. How long has Siemens been pursuing these products, and is this, we don't think of you guys as a Silicon Valley type of company, but it sure sounds like the products could be.
Well, the hardware and equipment capabilities have been around a long time, well over a century. As I mentioned, the introduction of the software and the high technology capabilities has been in work for decades, but acquired by Siemens back in around 2007. That integration has been maturing for the last 20 years, and we're very proud of the progress that we've made and the acquisitions that we made along the way to add critical capability to fill areas where we felt it would make our offering much stronger, to be able to build that completely comprehensive digital twin across the life cycle. Things like Mentor graphics for EDA and wire routing and electrical and chip design, as well as the recent acquisition of Altair that brings significant capabilities, especially to aerospace, for artificial intelligence and simulation. So our offering across the life cycle, not only for aerospace and defense, but for many verticals, is extremely robust and very complete.
Sounds like you guys have a suite of the tools that'll provide JetZero some competitive advantage as it begins to change the industry. Thanks for joining us today.
Sure, happy to be here.
Recording stopped. We can all breathe.